right? So we have a load coming down here, right? So this is equal to omega naught L divided by 2, because we are looking at the entire length now, okay? So this is our BY, right? This is our BY, and this is our AY, okay? So for now, I have not a clue how my moment will be acting at AY. Okay, I don't know. I'm just gonna assume that moment about A is acting in this direction. Okay, that's an assumption that I make. Okay, so I'm gonna assume it to be going in the positive direction. Okay. Later on, if it's incorrect, okay, you will have negative. You just change, flip it over. Okay. So we know the distance from here to here. Right. This is equal to 2L over 3. That's what we know. Okay. So the first thing we do is we do summation about forces in the y direction is equal to 0. So you have AY plus by BY minus by omega naught L over 2. The whole thing will be equal to 0. So now we have AY is equal to omega naught L over 2 minus by BY. Okay. So I'm going to call this my equation number 1. Then we're going to take moment at point A. Okay, so we're going to take moment down here now. So we have moment at A, we assume it to be in the positive direction. So moment at point A is positive, right? Then the omega naught L, the equivalent load, is going in the clockwise direction. So this is minus omega naught L over 2 multiplied by 2L over 3. Then plus by BYL, the whole thing will be equal to 0. So we have moment about point A. Okay, moment about point A is equal to omega naught, right? L squared over 3 minus by BYL. Okay, so this is my equation number 2. Okay, now then from here we can start doing our bending moment equation. Okay, we can start doing our bending moment equation. Now, why did I go into our bending moment equation? Because there's no point looking at the shear force, because we cannot solve anything. Why we cannot solve anything? Because we don't know our boundary condition at V is equal to X. When X equals 0, what is the V? When X equals L, what is the V value? We don't know. Okay, so there's no point looking at the shear force. Okay, for this stage, you can directly go into the bending moment equation. Okay, you can directly form your bending moment equation. So from here, you understand what I mean? Yes or no? Right? So if I form the shear force equation, okay, if I form the shear force equation, it's not going to help us solve anything. Why it's not going to help us solve anything, or in fact, it will give us more issue, because we have boundary condition over here that we don't know. So what's the point of forming the shear force diagram, right? So the next thing that we do, we are going directly into our bending moment equation. So we are going to form our equation from point A to point B. Okay, so 0 x to L, right? So we have this is our AY. So our AY down here, we got it as omega naught L over 2 minus by BY. Okay, excuse me. Then we have our moment at point A. So this will be equal to omega naught L squared. Okay, omega naught. My L always look like a 2 over 3 minus by BY L. Okay, and then we know that we have a equivalent load. So our equivalent load is omega naught x squared over 2L. And then we know the distance from here to here. This is x over 3. So this is positive shear, positive moment assumption. Okay. So as I said before, directly I'm going for the bending moment. Okay. You no need to form the shear force, then integrate. What a waste of time. For this case, okay. So moment about point x. So we're going to take the moment at this point over here. So summation about moment z upon the slider at point x is equal to 0. Now this example is very unique because you have a moment down here. How are you going to treat the moment? Okay, so that's what I'm going to show you. Okay, so the moment at point A, right, is going anti-clockwise. So there's moment at point A, right, and then minus ayx, right, then plus by omega naught x squared over 2L, right, multiplied by x over 3. And then you have plus by m as a function of x. This is equal to 0. Right? So you find that the moment m as a function of x is equal to ayx, or is equal to minus moment about point B, about point A. Then plus by ayx. Then minus by omega naught x cubed over 6L. Okay, let me check. It is late already, so but I have to be sure. Okay, so now you substitute your MA. Okay, so this will be equal to minus omega naught L squared over 3. Minus is plus by BYL. And then plus by omega naught L over 2x, right? Minus by BYX, right? Then you minus by omega naught x cubed over 6L. Okay, so let me check. BYL plus, can you simplify any more? No. Then after this, right, immediately say that this is equal to EI d squared y over dx squared. Okay, so let me recall what we're trying to do down here. We are trying to find, okay, so recall, we are trying to find by. Okay, we're trying to find by. And as you can see over here, as you can see what I've written down here, when I've wrote this expression over here, right, there's no more function that I could create. That is why this structure is what? Statically what? Indeterminate. I repeat again, right? We do summation about forces in the y. We take moment already. We no need to do summation moment about x because it could be 0. So that is why with this analysis, we say that this structure is statically what? Indeterminate. Okay. Okay. So from here, I'm going to split the page into two. As I said, we are going to find by now. So I'm going to copy this expression. Don't worry, okay? I'll zoom in, okay? I also can't see this way. Okay, so we have this expression over here. So immediately from here, you can find our what? We can find our EI dy by dx. Okay, so EI dy by dx. So you integrate the whole thing. So you have minus omega naught L squared over 3x plus by by Lx plus by omega naught Lx squared over 4 minus by byx squared over 2 minus by omega naught x4 over 24L. Then you now plus by what? Plus by C1. Okay. 4, 2, 3. Okay. So we can now substitute. So I'm going to call this equation. Did I write equation number yet? So 1, 2. So this will be my equation number 3. Okay. So from here, we can substitute one of boundary condition where x is equal to 0, theta is equal to 0. So we're going to substitute x is equal to 0, dy by dx, which in this case is also equal to theta, the whole thing equal to 0. So therefore, C1 is equal to 0. Okay, so we know that E over I, dy over dx will be equal to this entire expression. Okay, without the C1. Okay. So this is your equation number 3a. Right, this is our equation 3a. And then we integrate again. So this will be equal to minus omega naught L squared x squared over 6 plus by by L x squared over 2 plus by omega naught L x cubed over 12 minus by x cubed over 6 minus by omega naught x 5 over 120L plus by C2. This is our equation number 4. Okay, so we are lucky that we also know that this is equal to 0, right? So we substitute when x is equal to 0, y is equal to 0. So therefore, into equation number 4. So therefore, C2 is also equal to 0. Okay. So from here, we are left with EIY. I'm almost done. Okay, give me no more than 5 more minutes. We are almost solving it already. I know some of you say, how are we going to solve this? Okay, so we're going to have this expression over here. Okay. Right. So this is our equation number 4a. So we have one more boundary condition, right? So one more boundary condition is when x is equal to L, y is equal to 0. When we substitute the equation, hopefully we can find what is what? By, right? Okay, so we're going to substitute x is equal to 0, y is equal to 1 into equation what? 4a. Okay, so this is 0 minus omega naught L to the power 4 divided by 6, right? Plus by by.
Eugene,
Yes.
shouldn't be x equals L and y equals 0?
Oh, you're right. I'll get you a pint when I see you, Colin. Thank you.
Okay, next year.
Yeah, with this government, I'm not sure, you know. Plus by omega 4. I think your winter term might be a hybrid, okay? By L cubed over 6 minus by, I'm a bit lost now, okay? Minus by, there's something wrong. Oh, this expression, this is 5, sorry, x5. Somehow when we copy, it's not really good. I mean, when I copy, not you, okay? So omega naught L4 over 120. Regardless, I will get to see you, Colin. You get your beer, okay? Right. So you can see what's going on now. We can solve for by, right? And so this will be equal to 0. So minus 1 over 6 plus by 1 over 12 minus by 1 over 120. So I have minus 11 over 120 omega naught L4 plus, or I don't know plus or not. So half minus by 1/6. So half minus by 1/6, okay, is by L cube over 3. Okay, so you have by L cube over 3 is equal to 11 over 120 omega naught L4. Okay, so by is equal to 11 over 40 omega naught L. So the positive means the reaction force is going upwards. Okay, so this is the power of this technique over here, where we integrate what? Where we use elastic curve. Okay, now the question, my last question is this: why we can't use the elastic curve or the integration method? Why do I use this? Okay, and the answer is simple. From here, then I can create ay as a function of what? By, right? So at the end of the day, we are trying to solve for what? By. Okay, so that is why I have taken this route. If I were to use just like, I'm not saying you can't do it, you can do it. If I were to use just forming an equation that integrate 4 times, you can still do that. Okay, I'm not saying that you can't. Okay, I decided to choose this method because the first thing I realized that I'm going to try to find by. Okay, so I need to express the function or the equation as a function of what? By. Then at the end of the day, I can solve for what? By, as you can see down here. Okay. Right. So that's all for today. So what's going to come in is you are going to get 2 more quizzes coming in within the same week, and I'll give you extended time. Don't worry. Okay. I'll give you extended time. And next week will be our last week. Okay. And next week, we are going to focus on mole circle. Now, I'm going to post at least another 1 hour of lecture, okay, to go through the integration method, okay, to go through the integration method if you have distribution without what? Without distributed load. Okay, so I'm going to go through this example online. I'm going to record video like what I've done last week, and I need you guys to watch this. Okay, I need you guys to watch this. So it's going to be an hour extra of video that I want you to watch. If that's the case, I'm ending my lecture now. Okay, anyone, any question, please?
Are we doing a review next week, or is it just more circle?
Mole circle, okay? We're going to go through mole circle.